Okay, hello. It's a great pleasure for me to welcome you at our webinar From Manual to Modular, Automating and Scaling Snowflake Operations. I'm Rafał Rozpondek, CDO of Datumo, and also today we have Mateusz, Sułek and Przemysław Sapkowski, who are senior data engineers also at Datumo. We'll start from a few words about Datumo company to introduce ourselves. Then we'll move to our three main topics, which are manual account management, dispersed and unversioned business logic, sharing data outside of Snowflake, and also we'll have some time for Q&A session after. Few words about Datumo. Here is a nice quotation that describes what Datumo is. That Datumo is all about people, data, cloud, and AI solutions. We are partners with Snowflake, Microsoft Azure, and Google Cloud. We are founded at 2017, and since that time we delivered over 40 long-term projects. We have over 60 experts on the board. We are present on 7 international markets as well as in Poland, and we are a fully remote company. What might be interesting for you is that Datumo originally started as a product company. The product was open source data platform built around Apache Druid in cloud. So we can say that we are early cloud adopters. But in that time, we shifted more towards data consultancy model. But we are still benefiting from the product that we created as we use parts of it as frameworks to speed up development process, to speed up architecture and building of modern data platforms because we can use some parts of the products to speed it up and make it cheaper for organizations to implement modern solutions. So as Datumo is all about data, here you can see our services that we provide. As we create data platforms, we migrate them, we modernize data platforms, we engineer data pipelines, we perform observability and FinOps, we create real-time systems, and also we develop and deploy AI models. So in today's webinar, we would like to compare 2 different approaches when it comes to managing Snowflake data platforms. One is the manual approach, and the second one is modular and automated one. Firstly, let's ask ourselves why there can be manual processes in our Snowflake data platform. It can have source in different case. So it's the situation that I can think of. It's probably that we migrated from some other databases to Snowflake directly, and we went for lift and shift approach. So we took our solutions. We probably used some features like SnowConvert to translate our queries to Snowflake, so we can really quickly shift to Snowflake and benefit from its capabilities. And the second one that I can think of, that probably when we start implementing Snowflake in our organization, when we start small, with a team consisting of few members with probably gigabytes of data. And as we can see how Snowflake is reaching features that we can apply, the business wants more and more use cases to be implemented to our platforms. We grow rapidly. It escalates that from gigabytes, we go to terabytes and probably petabytes of data. From few members, it goes to hundreds, maybe different teams or even cooperation with some external organizations. And when we think about automating and making it more modular, it's always left for later. But then we can face those challenges that are listed here. Probably not all of them are applicable to most of the organizations, but from our experience, it seems that at least some of them are still present, even in big projects when it includes hundreds of users and terabytes or petabytes of data. And as we keep manual approach, we'll see that we have issues with onboarding new users, with managing proper privileges. We don't have version control and proper deployment standards. And as a lot of people, we start working on our Snowflake account. If we don't have proper standardization of processes, it will be hard to track the logic and to choose the most important processes. And it will be also hard to build proper trust in our data. Also, the other topic that today we want to mention is possibilities of sharing data outside of Snowflake. Snowflake has a lot of great features that enables data sharing with partners, with other members, but most of them were built around Snowflake, and it still needed integration directly with Snowflake. So even if we have reader account, which can be used to share data with some external organization or even with another team inside our organization, there will be still need to integrate with Snowflake. And here, Iceberg and Polaris, which are very nicely integrated in Snowflake, comes to play, that we can use it and share it without this overhead. Also, here are two more challenges mentioned about scaling and cloud cost management, that if we address it properly and we go to a more modular approach, it will be definitely easier to scale and definitely easier to manage our costs. So about benefits that you can get if you choose to go fully automated solution, we can definitely accelerate time to market. So adding new objects, spinning new environments will take minutes instead of days. It will be much easier for us to control costs, to optimize our spends at Snowflake data platform, because we will reduce risk of human errors and we'll be able to pay only for what we actually need. We can, in much easier way, achieve audit-ready compliance, as well as will increase our trust in data, which will also result in increasing quality of our reports and dashboards. And if we can trust our data, we know that our reports are valid, it will be much easier to make a decision based on data and will become much more data-driven company. Also, if we have proper standards, proper versioning, it will be easier for us to respond to business needs faster, to implement needs in much more convenient and faster way. So our analytics will spend more time on insights instead of troubleshooting, because if we don't have these processes when implementing new logic, especially a complicated one, would be much harder, because probably different teams will do exactly or very similar process in much different way. So it will be harder to maintain the data platform. And about data sharing, if we integrate Polaris and Iceberg to our data platform, it will be much easier to share data with other partners. We won't need to create some specific export pipelines. We won't need to duplicate our data. There won't be a need to integrate with Snowflake if we are sharing data with partner that does not have Snowflake in their stack, and they will be still able to query our data, or even, if it's of course needed, to modify our data. So we can not only share, but we can modify the data together with partner, which will bring us to more data-driven company. We will start thinking of a data as a service. We'll create our own data products, which definitely can open new revenue opportunities. And about the tools that can help us to achieve it, I can distinguish 4 different groups, which are as follows: simple automation tools like SQL scripts, Python scripts, or Snowflake CLI. There are some CI/CD tools, there are some Snowflake-specific tools and platform-agnostic tools. And the biggest difference between Snowflake specific tools and platform agnostic tools is that those who are in the bucket of agnostic we can use with different other solutions. So it can happen that you already used, for example, Flywheel or Liquibase for your previous solutions, and now you can use exactly the same tools when you implement Snowflake in your organization. And in today's webinar, we picked 3 of them. It's Terraform, Liquibase, and dbt. And we'll show you how you can start working with those technologies, but you can achieve exactly the same results using other tools.
Okay, so thank you, Rafał. Let's move to our first topic and first challenge, which is manual account management. So when it goes to account management, at the beginning, when we are starting out with Snowflake, we can easily do it by using only the excellent Snowsite UI. But well, the problems will arise when we're gonna scale up our operation, our data platform. So then when we will have more objects to manage, it can become really inefficient and error prone to actually take care of all of them. So like creating lots of new users or maybe removing them, adding schemas, databases, and all the other different types of objects can become really time consuming because we would have to click through all those UI windows, and there won't be really any native change tracking. So it's became a bit hard to actually keep track of what changed and when and who made the change. So this leads us to risky situations where we can actually misconfigure something, and like the simplest example of that is a user who doesn't have enough access and is actually blocked from performing his tasks, or maybe in some in other situation we can have a user that actually have more access than he should have, and this can actually create some serious security risks, and by like giving access to a data that shouldn't be viewed by someone. Now how to actually approach this kind of situation. So we want to achieve account management automation, and we want to have a situation where we have a good process for change management in place, so we can do the changes in a repeatable way, and this will help us prevent the errors and these misconfigurations, and this will greatly increase our productivity when it goes to managing many different objects at a time. So how to achieve it is to actually we have to adapt new tools and new processes around management of our account, and this will also what will also be necessary is some skill in our team. We'll have to have some kind of skills regarding the version control, the continuous integration and continuous delivery approaches, and also, of course, infrastructure as code. So this may be a bit of a challenge for some organizations, but here Datumo got you covered, and we can always help you with that. So now we're going to discuss just briefly about the tools that we chose to show you that we can achieve with which we can achieve this account automation. So the first one is Terraform. This is one of the most popular and effective infrastructure as code tools. Terraform is actually mostly used for managing cloud infrastructure, but it can also be used to managing Snowflake accounts. With one of the nicest features of Terraform is the Terraform state. So it is a really nice thing that helps with managing the state of our infrastructure. Terraform gathers the information about how our infrastructure looks, and then simply compare when we choose to plan some changes using the Terraform plan command, we can quickly and very clearly see how our configuration that we have written in code in our repository is different from the actual state of our infrastructure. And then by using the apply command of Terraform, we can request Terraform to actually perform the changes that we written down in our configuration. So now the thing with Terraform is that to actually use it efficiently and securely and use it in the best possible way, it's not that easy to actually do it. There is a bit steep learning curve when it goes to ACL language and actually simply like setting up the whole project and using the Terraform. And so this may be a bit challenging for some organizations. And also when it goes to Snowflake provider, so the let's say part of Terraform that helps it communicate with our Snowflake account, there are some limitations, but the provider is under active development and it is all the time improving. So very soon it should be working with it should be a much better experience. Now the second tool which we choose, it is Liquibase. So Liquibase will help us a bit mitigate some of the limitations of the Terraform provider. So Liquibase is a database migration tool, and well, in Snowflake we can do everything with using SQL. So this Liquibase tool will work just fine. And in Liquibase we are expressing our changes using changelogs, and we can write them in SQL, we can write them in YAML, JSON, XML. Those changelogs will contain change sets inside which we are writing what kind of change we want to apply to our account. Then when we applying those change sets to our account, Liquibase will track which change sets were applied, which should be applied. And so maybe it's not this tracking capabilities maybe are not as clear as when using Terraform, but still we are covered in here and we know which changes that we specify in our configuration were actually applied to our account. Now, what is really nice about Liquibase in comparison to other database migration tool is this flexibility of configuration, which we'll see in our demo. And yeah, just to mention at the end, when it goes to Liquibase, yet there is a bit different way of working than with Terraform, because as I mentioned, we have these changes that will be applied to our infrastructure and there isn't really a state. So maybe sometimes it may not be that easy to actually check how our configuration and our infrastructure actually compares, especially not that easy like with Terraform. So now let's move on to our first demo. I will share my screen and you should see in a moment in the media player our Snowflake account. So here we can see the webinar DB. We can see that was created using Terraform. The same, we have some schemas that were also created using Terraform. We have some tables that were created using Liquibase, and here inside your out schema we will also have some tables created using Liquibase. Now let's take a look at users. So let's run this query to see how many users like webinar we have in our account. We can see that there is only one. Now by using Terraform, we can quickly do some changes to our account. And here is the configuration written using Terraform. This is the HCL language, and these are the services, Snowflake resources defined in Terraform. So we can see here a role defined, a user that we saw a second ago. We also have the definition for database and all the schemas that were created. So this configuration was already applied to our account. Let's run maybe Terraform plan command to check if our configuration is in line with the infrastructure. As we can see, there are no changes. So this means that our infrastructure matches the configuration. So as you can see, we can quickly check how it looks. Now let's try and add this user. As you can see, we are simply adding the configuration for the user to our whole rest of the configuration. Now we're going to run the plan again, and we can see that Terraform discovered that we are trying to create new user. Now this plan command will only show us that we actually trying to create some user. Now let's try and apply the changes. And if we click apply, Terraform will ask us if we want to do it. Let's do it. And now the creation was complete. So we have this new user created. Let's check if it's already there. Let's query the metadata. As we can see, now we have these two users available. Now, you can see we have everything under version control. So this change will be visible in our repository and can be like tracked. Now let's try and maybe delete this user. We can just, one of the nice features when it goes to Terraform, we can simply remove the definition from the configuration. We can run Terraform plan again. And what we will see actually is that we have all the user, and we can see that there is a lot of additional parameters that were set up on the user by default by Terraform, because we only specified some of them. But yeah, here you can see that the user will be deleted now because we removed it from the configuration. And also these are all the parameters that we can also specify using Terraform. So it's then really easy to actually have some kind of common definitions for user and things like that. Now let's apply this. Again, Terraform will ask us if we want to do anything with the configuration, and the user should be deleted. Yes, so this is when it goes to our demo with Terraform. Now let's move on to Liquibase. So here we can see these database changelogs of Liquibase, and these ones are actually specified using YAML. But the changes that were applied to our infrastructure, so with the tables that we created, are defined using SQL, like in here, for example. Yeah, we can do it like that. Now with Liquibase, we can have one root changelog, and now by using the status command, we can check if all the change sets that we defined in our changelog were applied to the account. As we can see, we are up to date, so there are no pending changes. So maybe let's now try and uncomment this part. Here we are including in our main changelog the changelogs from the tables folder, where we actually separated configuration for every table into separate folders. As you can see here, we also have separate one for the Iceberg tables, and this is this flexibility of the configuration when it goes to Liquibase. Now here we are creating the. Let's check again if Liquibase will pick up that we want to create something. Yeah, so we have this changelog that we included in the configuration, and here we can see that Liquibase will try to create this new table called webinar. Let's perform update, and here we are having it defined in YAML actually. So Liquibase will translate it to proper SQL to actually create the table. And so this is also possible for some of the objects. And the table, yeah, so we have it created. Let's just check if the table will be within row schema. As we can see here, the table is now created. Let's check out how the schema looks like. We should have 2 columns, yeah. And now what we're gonna do is actually something that currently is not actually possible with the Terraform provider. So is to perform an alter on a table. So let's quickly add this new change set that adds a column to our table. Let's see if it's present. If Liquibase will note that, yeah, we are actually have another change set not applied. So let's use update, and now our change should be applied. Yeah, so we can see that everything succeeded. Let's refresh the schema of our table. We can see that new column webinar date, which was specified in here, was added to our table. So that's all for the first demo. This is how we can do it with Liquibase and with Terraform with our account. Now I will, now let's hear from Przemek, and he will pick up another topic. Thanks for now.
Great. So speaking about our next topic, let's stay in dispersed and unversioned business logic. And in 2024, consulting company called BARC conducted their data, BI, and analytics trend monitor for an upcoming 2025 year. And they've gathered a sample of around 1,800. And they've conducted the interviews for the data experts, asking them what are the most important topics in data area according to them. And those experts highlighted the 4 main topics, which are data security and privacy, data quality management, data-driven culture, and data governance. And we've analyzed those results. And there's a saying that before you can jump, it is better to start to learn how to walk. So to do some advanced concepts and advanced analytics like BI forecasting or machine learning or artificial intelligence models, which are a hot topic right now, we have to have a solid foundations for them. So provide a good quality of data, check the results, and put in place some standards to the organization. And based on the survey and our experience in Datumo, we've investigated 4 main quality and governance problems that are oftentimes occurs in so-called legacy architectures. And first of these problems is business logic that is spread across multiple systems. When we are looking from the perspective of data analyst who has only access to a Snowflake and some models breaks, and this analyst has to track the lineage and get the root cause analysis of the problem. Sometimes he is unable to do so because of lack of the permissions to the source system, and it can only track the transformations to the root table in Snowflake, but nothing beneath this horizon. And he's missing this business value that he could get otherwise if all the transformations would happen in one platform. Second problem is unversioned business rules. And here we're speaking about the situation when we are not using the source control systems like Git, when we are only doing the modeling and transformations via some interface like CLI or UI in Snowflake, and when we are creating the views that should highlight the results of our analysis. But the logic may change over time, and let's say in this example, after a month, some new rules should take precedence, and we apply those rules. But after some time, once again, the rules should fluctuate somehow, and the person who is seeing the report would like to ask us how was the old rule, how the data would flow through the models when we would apply the business logic that happened a month ago. But we are unable to respond to such questions because, once again, we are not versioning control anything. We don't have the view of the revision history, and we are missing the information in process. The third problem is documentation done late. Oftentimes in this legacy approach, the documentation is in Snowflake is done seldom or oftentimes not done at all. So we are not documenting our models, columns, or other objects inside Snowflake. And afterwards, some companies then decide to buy some external data catalog and then to catalog, govern, and describe the data in those catalog. But in a lot of cases, it is redundant because we can do the same as well in Snowflake, and we don't have to pay for two systems that have the same purpose. But during the modeling and the transformation phase, people often forget about putting the columns, or nobody requires them to do so. And the last problem that we identified is the lack of standardization when we don't have the processes that I put in place. First of all, the same KPI can be named the same in multiple different departments, and the analyst who would like to do some meaningful analysis is unable to identify which one should he use, or he has the same KPI in 5 different tables. And writing a select statement is quite easy as long as we know which table should we select from. And we don't know that, it is a burden to track the dependencies, to go to talk with different departments, different people, and to do on our own this governance and data discovery phase, because once again, it takes a lot of time, and time is money. So to mitigate those issues and try to resolve them, we can leverage dbt workflow on Snowflake, leveraging also the ELT approach. ELT means that we are trying to extract the data from source systems and load them into our warehouse platform with as minimum of transformations as possible. And we can model the data in so-called medallion architecture. When each higher layer has the better standards, it's more curated and more ready for the reporting purposes. So let's start the process from left to right, and our engineering team can load our data to our bronze layer, to this table's row customer and row orders as presented in the diagram. Then leveraging dbt, we can implement the tests on those models to provide and to add the data quality. After the tests, we are implementing the silver layer, the curated one, which is standardized across our organization. And to this layer, we are adding also the documentation in the same dbt project in line with our business logic in separate files. After the silver layer, we can as well add some quality tests and let our analysts prepare the data marts on the gold layer suited for their reporting needs. And those data marts as well should be documented and well tested. And dbt lets us properly version control all of the transformation logic. It also provides us the capabilities to add some CI/CD checks as long as all the transformations are in code in project structure. And we can automate the quality assurance, not to propagate the unnecessary and untested changes to downstream models. And to sum up the Snowflake and dbt synergy, in this approach, we are treating the Snowflake as a centralized data platform for storing and computing. Then we are leveraging the dbt as a tool for transformation and pipeline management, and using its features such as tests, documentation, and native version control to store the history and track changes. And as well, with dbt, we can implement some advanced Snowflake concepts, not only basic tables or views, but also some materialization strategies as dynamic tables. And to add things to that, recently during Snowflake Summit, there was an announcement that dbt projects will be available to run directly inside Snowflake platform. And this feature is currently in preview, but will be in public one soon. Okay, let's now move to the demo and compare this legacy approach with the new dbt workflow that we can integrate. And once again, let's change focus from the presentation to the media player and look at my Snowflake UI. And once again, we are in our webinar DB. And let's think about the scenario when some data engineers load the data to our row schema. We've got here the customer table, we've got the orders table. And in this legacy approach, if I would be a data analyst, create a schema, say for my own department, it's called the legacy department. And here I would create the destination table based on this raw data called orders by customer. But as you may see, there's no description, there's no comments, there's no constraints for my table. So the governance capabilities here are quite limited. As well, I cannot see any description in this UI tab. What's good that Snowflake is providing us is the lineage that we can track the dependencies between the source tables and some transformations that are done on the fly between the raw layer and the destination one. And for the transformation, we've created the procedure that is upserting the data based on the raw tables. But once again, this procedure was just created via UI. There's no version control. If someone with the same privileges will update the procedure, I won't even know and may start using the new logic without any notification. So quite limited capabilities to govern and track the changes and the transformation logic. And now let's see the dbt project and how it may be structured. On the left-hand side of my IDE, you may see the project structure. And for the purpose of this demo, let's only focus on this models folder. And the first file that we'll track is the _sources.yaml file, in which we are describing our sources, this bronze layer, which will be basing our further models. We are describing the database, the schemas, and we are specifying the tables as well. And as you may see here, I'm implementing some data tests to the specific columns, the unique test and not null test. And it is as simple as that. I don't have to create my own business logic. I may just use the native and out-of-the-box test provided by dbt or its ecosystem to do. When I've got my sources file described, then I can do some modeling on the other layers, and eventually I would create my gold data mart called orders by customer. And the first part is the config, when you may see we are providing some specification regarding to the materialization. In this case, it's a dynamic table, so we have to as well specify some compute for it in the target lag. And we are also specifying the documentation that we would like to persist for relation and column level. Then we are providing our transformation logic, and it is as simple as writing select statements where we don't have to worry about any DDL part because it is done by DBT itself. When the model logic is in place, I can provide the governance part to it. And in this YAML fight _ models.yaml, you may see the description for my data mart, orders by customer, the contract enforcement, the DBT test once again, and some further descriptions on column level. And here you may see that I'm leveraging the data test from external DBT package called DBT expectations. So even for some advanced tests like this one, I don't have to create them on my own. There's vast amount of packages written by a community. If I would like to materialize my results, my logic in Snowflake, I can just run the dbt build command, and it will resolve the dependencies between my model and run the whole pipeline. And you may see that it is building 10 objects. 3 of them are dynamic tables and 7 of them are the data tests. And I've got the log information that 9 of them accomplished successfully and 1 of them failed. And now let's move back to the Snowflake UI. And in our department schema, you may see tab dynamic tables. We've got our 3 models. We've got the order by customer model. And here you may see this extensive description that that is informing the data analyst how he can use this model, what are the use cases, what are the pain points as well. Our columns are also described, and as long as we are using the dynamic table feature, we may see some advanced concepts like dynamic table graph or the refresh history for the model here. Also, we can materialize the results or the logic for our tests. And you may see here, there's another department schema with suffix dbt test audit. And here we've got the results of 7 data tests that we've applied. We may see the test logic. This one is quite simple. And we may use the data preview tab to see the results if it's passing or failing. If we are seeing no results, it means that the test is passing, but we can try to find the one that failed. And here you may see that we've got some results, meaning that the test is failing. We may move back to the view definition, go to Snowflake worksheets and investigate what is not working, and get to know our data analysts, how they can improve the processing of the data in the pipeline. Thank you very much for the attention in this part. And if you have any questions regarding DBT synergy with Snowflake, just add them in the chat.
Okay, so let's move to the third and the final part of our presentation, webinar. So now we will discuss the sharing data outside of Snowflake. So sharing the data outside of Snowflake, it isn't really a challenge. There is a rich set of features that we can use to actually share the data. We can either do data unloading, we can make use of listings, shares, and the data exchange. So a lot of excellent Snowflake features. Now the thing is that we have to either use the Snowflake warehouses to make this data available, or we have to set up some kind of access to our Snowflake account, or we can share only with users that organization partners that also are using Snowflake. And it's nothing wrong with that, but let's take a look at the Snowflake Iceberg tables, which are now another excellent feature for actually sharing the data outside Snowflake, and this feature makes it even more flexible. And because, well, when it goes to Snowflake Iceberg tables, we have, let's say, a table that have the same capabilities and performance as traditional Snowflake table, let's say traditional. And the main difference is that the data for the table is stored outside of our Snowflake account, somewhere in an external cloud storage that is managed by us, not by Snowflake. So we can actually achieve data sharing without any additional warehouse costs or without adding any Snowflake access to our account. And this makes it really nice, because then we can also the data can be read by using different compute engines outside of Snowflake. So let's move now to our demo for the part third. I will share the screen. And okay, so here in our Snowflake UI, we using Liquibase, we created this Iceberg customer table. So this is Snowflake Iceberg table. We can see that you can see it in definition. The DDL looks very similar to the traditional table. What we can see is that we have to provide the where the data will be stored outside of Snowflake, in which part of our external storage. And what we also did when it goes to this table, we synced it with the Snowflake Open Catalog, as we can see here. So Snowflake Open Catalog actually implements the Iceberg catalog protocol. So Iceberg catalog is a part of Iceberg specification. One of the main one of the main functionalities of the Iceberg catalog is to actually track the current version of the table, because just like with the other tables, we have the time travel and other capabilities when it goes to Snowflake Iceberg tables. And using the catalog, we can easily through it read the newest version of the data in the table. So yeah, now to read this data, we only then actually need the access to the catalog, and we can use different compute engines to read this data through catalog. Now let's check if there is any data in our Iceberg Snowflake table. As you can see, we can query it just like the other Snowflake tables, and we can see here that there is no data in the table. Let's check it in our notebook. So we're gonna use PyIceberg. So this is a Python implementation of Iceberg. It's a library created by the Iceberg community, and it helps with interacting with the Iceberg tables. We're gonna connect to the catalog. We're gonna load our table, and we should see that here also we don't have any data. Now let's try and insert some data into the table. We will do insert, let's say, 1000 rows. So now data is inserted. Let's try again. As we can see, we can instantly read the data without connecting to Snowflake. Right now, we only connecting to the catalog and to the data in the remote storage. Now let's check if, to check other functionalities of, let's say, the standard actions that you can perform on the table. Let's check if we have records where nation key is equal to 10 in the table. And in Snowflake, let's delete those rows. Now they are deleted, so we can again query it from our notebook, and we should see that there is no data for this nation key. Now for the another thing that we can do with the tables, let's try to do update. First, let's check if we have any rows where empty segment column has value of automobile. We can see there is actually that many, and we can see also that there are columns that have the machinery value for that column. And let's perform an update. Let's change all the automobile values to machinery. We can see that we updated the rows using Snowflake, and now we're gonna check again, read the data, and we can see that, yeah, there is no automobile records in here, and there should be more machinery records. Yeah, so in this notebook, we actually queried the data through the catalog. So we had we only needed to connect to the catalog. Now it's also possible to read the data without catalog by just accessing it through our cloud storage. In this case, it's S3. And the only challenge here is to actually have a way of determining which metadata file is the newest. So this metadata file will tell us, it will point us to the newest, to the freshest version of the table. And we just written a simple Python function that does it for us. We just provide the location in our cloud storage. We have to have proper access to it, at least a read, and then we can query the data using also, in this case, Iceberg. Let's check if the count for, of course, like in the live demo, something had to go get wrong, and we should see that the machinery should be there, but something went wrong. So still, as we can see, yeah, we can still query this data. I'm not sure what went wrong. Well, probably something within the code, but yeah, still we can query this data using the different compute engines, different approaches, and this makes it really, really flexible. Now let's stop sharing and let's wrap up by moving to our main architecture. So this is the high-level view of the architecture that we actually presented. What we can see here is our Snowflake account, and we have all this configuration, all our code inside version control. We have at the top, we can see that we use Terraform for managing users, roles, to manage, for example, the objects related to data sharing, but also database schemas. We have Liquibase that we are using to managing of schema for some of the tables in our row layer. We have the dbt for managing data pipelines, data movement, transformations through the layers, through our pipeline. And also in the gold layer, we can see that we have some Iceberg tables for which we can use external compute engines to actually read data from them and work with them. So now let's take a quick look on how these different technologies, how we can utilize them together. Now, when we have an account in which we can easily drop everything and then recreate it, we can, as of now, we can use only Terraform to actually manage the whole account, and probably when the provider will get better in the future, maybe this will be possible to actually possible to do for every account. Right now, we can mix Terraform with, for example, Liquibase in situations where we are actually not using dbt for data pipelines. Maybe we have some logic in stored procedures, maybe using tasks for orchestration. Then we can use Terraform and Liquibase together to manage our account. When we are using dbt, a very good combination is to use Terraform for the account level objects, for access management, things like that, and then dbt for everything that we do with data. And as you saw with our architecture, we can have all the three tools for actually managing our infrastructure, but maybe it's not really that necessary. In real world, it may be a bit too much because of the overlaps between the tools, and it's always better to have a bit less of them. And here, when it goes to recommendations of on which objects to manage with which tools, and when it goes to accounts, warehouses, databases, schemas, on the integrations, all those, let's say, account level objects, things like that, the Terraform is the best solution. Actually, it may be even not possible with the other ones. When it goes to users, roles, grants, so general, the access management, the Terraform also would be the best choice for that. Maybe when it goes to Liquibase, we can use it also, but it won't be that nice, that easy like with Terraform. When it goes, if we have some stored logic like inside stored procedures, UDFs, things like that, then Liquibase will be the really good choice for that, because we can keep everything in SQL, use Liquibase to actually add those, manage these definitions in our repository and then just deploy them. And when it goes to tables, views, dynamic tables, so all those let's say data containers that we have within our account, dbt and Liquibase are the best choice to actually work with this type of objects. And well, that's all for our presentation. Thank you for your attention. And if you guys had if you are having any challenges with data platforms inside your organizations and you need someone to need some help maybe, then here you can see the Rafał's contact information. And also, just to mention at the end, we are hiring, so if you are interested, just visit our site and look for open positions. And well, that's all. So thank you, and if there are any questions, probably now it's the time for a Q&A session.
Thank you, Mateusz. I don't see any questions for this moment, but maybe let's wait a few more seconds if anything will come. Okay, so I think that will be all from our side. Once again, thank you very much for your attention and your presence, and see you afterwards.